So I believe I'll start now. My name is Eric Evans, and I'm best known for the concept of domain-driven design. That's DDD. And today I'll be talking about a certain aspect or a few aspects of domain-driven design that are, I think, applicable to microservices, or perhaps from my perspective, the reasons that I found microservices to be an exciting opportunity for people trying to do domain-driven design. That's really what I'm more interested in. So, starting out, I want to just briefly point out what are some things that got me interested in microservices in the first place. Well, I certainly was inspired by the stories I heard about what was done at Netflix. I think it's important at this point to recognize that microservices come in many flavors. So I don't think that the things that I think of as microservices are necessarily representative of everything everyone is doing. Certainly, what I say is based on my understanding of what they did at Netflix mostly. And the creation of truly isolated place for an autonomous team to do development was the single thing I think was most important to me. Because for as long as I can remember, I've been advocating, for example, that a team that's developing some complex piece of logic should have their own isolated data store and not have to share some huge database that has some kind of mishmash of different people's ideas of what the data should be and so forth. The free-for-all of that makes it very difficult to do sophisticated modeling and subtle designs that can solve intricate business problems. So that was one of the first things that I thought, wow, we could really use this. And I started trying to get some people on projects that I was on to adopt that. Just say, let's just isolate a piece of business logic, put it at the end of a message queue, and say it can't share data with anything else except what's sent through that queue, and see what happens. And it was a very interesting, very successful experiment. Required going back and saying, well, see, you still have a connection to the other database, don't you? So let's keep going. It was funny how persistent those attitudes were. One of the things about microservices is that it seems to acknowledge the rough and tumble of enterprise development in a way that most philosophies of software development do not. One thing that I am more than tired of is sort of idealistic views of software development and software systems, large software systems. It just isn't like that. There's so much going on, and it's so rough and tumble is the phrase that always comes to my mind. Now, if what you want to do is to address an interesting and intricate problem with a subtle model, those things are fragile. Those things are like snowflakes, and you have to have a way of having those exist within an overall rough and tumble situation. And a lot of times when people start talking about doing sophisticated design, it's a few steps down the road, you realize that part of the idea there is that the entire world will be redesigned and everything will be very elegant and tidy. And that will never happen. So if you value good design, then you value ways of isolating those things from that outer world. And you have to have a philosophy that fully acknowledges the reality of that. I think that there is a kind of boldness to the microservices philosophy that really appeals to me. And I think that things like Cattle Not Pets and the Simian Army just really inspired me with their boldness and innovation. Now, these are mostly runtime considerations. You know, you deploy something, and that's when you treat it as livestock rather than a pet. And you deploy things, and that's when you knock them down with chaos monkeys and so forth. So what's interesting is that this philosophy seems to have started from that perspective of deployment and then changed the way people actually do the development and design work. And that's a different, approach. I mean, in the sense of where you start and where you end up, than most of the software philosophies that I was exposed to earlier in my career. I think it's very interesting. It's a break from the past, and sometimes incremental changes don't work for various reasons. And one of them is that our mindset, when we see incremental changes, we perceive them as being the same thing as before. People don't realize that some subtly different concept is different. But when you have something that's a true radical break, then things get really shaken up, and it's a chance for people to think differently. That doesn't mean that everything that the microservices people do is going to work. I think far from it. It's like any new thing. It's going to have a lot of misguided things going on in it, but it's truly exciting new shakeup. So with this caveat that I think microservices does seem to mean a lot of different things to different people, this is basically where I'm coming from, and the things that I'm about to say are based on that perspective. Now, what is a service? Well, if we just take sort of a very basic, say that a service is something that can consume messages and produce messages, and in there, in between, inside of that service, anything could happen, right? It can have a lot of data, or it could have very little data. It could have a lot of logic, very little logic. There's a service. And so let's imagine that there are two services, and these two services actually use information produced by the other one through messages. Now, the question that I ask is, how do they understand the messages? How do I understand a message that's produced by another service? A service that is built by an autonomous team, right? A different autonomous team than mine. So the messages that they're sending out, they're not really necessarily sending them specifically to me, but the messages they're sending out are in some language. So I'm just labeling the messages according to the service that produced them. So the messages coming from A are in the A language, and the messages coming from B are in the B language. But how do they understand them? Obviously, the software is written in such a way that they can interpret these messages, that they can interpret any of the ones that they've chosen to consume. Now, understanding messages requires some kind of context. This isn't anything about specific to microservices. This is just the way language works. You can never understand a phrase that you hear unless you know the context. And so and this is something that I tried to make very explicit in domain-driven design, is that when we're doing models, that the most central thing about a model is often the language that you create that allows you to express the problem and solution very crisply. And to have that clarity of language, you have to make context clear. And in practice, in software, that means making an explicit boundary. Not the subtlety with which we interpret context in normal conversation, which is immensely complex, but simply drawing a line around something and saying, within this space, this is what this word means, these are the rules here. So I call that a bounded context. Now, we could say that A and B are each one of these bounded contexts. Within A, that establishes a boundary, and within B, that establishes a boundary, and inside of there, they've each defined their language. And we have established a translation between the two, and in this case, the way this story seems to be going, we're going to say that A and B do actually actively collaborate with each other. That is the people developing A and B. They collaborate with each other. We're going to call this a partnership, and that translator is a way of saying messages from A can be transformed into the B language and vice versa, and language B can be transformed into A, and they both care about that translation. Now C comes along. This is another service, and they are consuming messages coming from A. But this is not that kind of mutual collaborative relationship that A and B have established. C is consuming and doing something with these messages. But A is not as interested in C as they are in B. So this is an asymmetrical relationship, a kind of upstream and downstream relationship. And so when I put these onto this diagram, and this lower diagram we call the context map because it shows all these different contexts and how they relate, we put an arrow which says this is the direction where the power is. That is to say that the communications between A and B follow the decisions that A makes. Between A and C. Follow decisions that A makes, not decisions that C makes. So the arrow points toward A. Now, in a situation like this, C has to make a decision. How am I going to deal with that? The fact that I don't control the kind of messages that I'm receiving. In this case, C has made the decision that they will conform to A. That is, I will make my design compatible with A, so that the messages, the language of A, will be, my language will be a lot like their language. I will make it so much like their language that it'll be very easy for me to consume their inputs, their outputs. This output from A seems to be very useful. And along comes D, another service. And D also wants to consume the messages coming from A. But they've made a different decision. They've said the things that we need to do within our service are substantially different than apparently what the A people had in mind. It's sufficiently different and complex that we need to control our own model. We need to change the language. So we're going to put a significant translation in place. Now, there is a significant translation between A and B, but it's one that's managed between the two, and the two are coordinating their development. But D is not. They simply are consuming the A messages as they come. So we call this an anti-corruption layer. I'm going to build a little wall between me and you, and it will transform those incoming messages into a form that I will use. And it's no one else's business how this works. I think that all of these things happen, and routinely, whenever we have multiple teams developing independently and integrating with each other. It's helpful to make it explicit, have a picture of what's going on that people can see at a high level. Of course, microservices, the idea is you'll have many of them, and so now along comes E. E is going to actually provide some inputs that A will use. But they're going to do it in A's language. This is somewhat common. What it means is that for internal organizational reasons, perhaps, the A people are able to say, we need you to send us messages in this form. Now, this means that E is conforming to A. The direction of the arrows in a context map don't correspond to data flow direction, they correspond to the direction of the power. And A seems to be in a very influential position. So C conforms to them while they consume, but E also conforms, and they are providing A with information. All right, E is also going to send this same data to D. Now, D is now consuming messages in the A language from A and from E, but you'll notice that there's really no need to change the context map. The context map is not a map of where the messages are going. It's a map of who has to understand whose language. Where are the translation points? And basically, what decision did they make about their relationship to the other language? Now, F is going to consume B's language and emit things in its own. So C is going to consume those, and it has to decide. Well, C decided to conform to F, but F is not conforming to B. Now you might say, now C is conforming to F and A, which would be a problem if F and A are providing similar kinds of information. Right? If you were sending me a listing of movies, or if A is sending out a listing of movies and F is sending out a listing of movies, and I'm trying to conform to both ways of listing movies, that'll be a problem. But if one of them is sending me a list of movies and the other one is sending me some completely different information, let's say credit card statements, well, that's no problem then. I can conform to both. All right, so one point as we deal with how are we going to do modeling and make it a practical tool. One of the things that people often miss, I think, is that models need to be clear. They don't need to be big. One of the worst kinds of models that I've seen is the enterprise model, or things that are moving in that direction, where every piece of information that someone might ever want to use is somehow finds a home within this enormous schema, or where they are working out a way to compute almost anything within a given domain. The most valuable models that I have created and used in my career have been actually quite modest in scope. And this fits neatly within this idea of the bounded context. We need to have very crisp definitions. And for that, we need a clear bounded context. Also, the most interesting models tend to make assertions that simplify the interpretation of what's happening. And assertions require boundaries, because anything an assertion is simply making a statement and saying, this is true. This is always true. And you can almost never make statements like that in general. So you need a boundary. But with a bounded context, you can make such statements. So there are always multiple models. That is a good thing, and it's a thing that is very part of the air of microservices. I think it seems extremely natural in that kind of a paradigm. Now, as we go along in this, back to the story of our context map. Well, people don't always make good decisions. In the F context, they make a few poor choices about how they represent the data, about how they compute things. In general, it's a bit of a mess. And since C is conforming to F, that mess is immediately going to migrate into C. That is, if I conform to a mess, then what does that make me? So remember, the kind of design I'm talking about is where clarity is the premium. And F has lost the clarity. And as a result, C has lost their clarity. That's one of the consequences of conforming. There are good things about conforming, but this is one of the downsides. Now, E has made some poor choices. As a consequence of E being a bit of a mess now, the messages they're emitting, which are supposed to be conforming to A, no longer really are. That is to say, if I'm A, I'm receiving messages in a form which was supposed to be just as I had dictated, but it actually is not. This isn't a choice that the E people have made. It's just that they didn't pull it off. They just don't quite have the competence, or they just messed up this one time. So now what's going to happen? Well, in the ideal world, the pressure from A and D, the two consumers, would probably push them to get their act together and go back to emitting well-formed A messages in the ideal world. But I have never worked in the ideal world. In the world where I work, right now there is a great risk that both A and D are about to become corrupted by this. That the model of A will start to have to accommodate a little bit of E, and the same goes for D. And those gray circles are just going to fill the screen. But there is another possibility, but we'll get to that in a minute. This picture right now is a fictional picture. So by that I mean that what's really happening up above is that E is not conforming to A. But the picture still says that they are. So we're going to need to change that picture. We want the context map to reflect what is really happening, whether we like it or not. Now, not all of a large system will be well designed. I think that anyone who cares about good design needs to drum this into their mind, like say it 3 times to themselves in the mirror every morning, because if you don't do that, you'll end up without any good design. Because you'll overreach. You'll keep trying to fix everything, right? Making, but fixing nothing, spreading your work too thin. So the real question is, in this situation, yes, I mean, it would be worth looking into getting E to fix things up, but recognizing when they're not going to do that, what are we going to do about these two relationships? Right now, there's no real clear way to write this thing onto the context map because it's just not a good situation. For the most part, the patterns in the context mapping technique are ways to describe reasonably healthy relationships. One way would be for each of them to introduce an anti-corruption layer. For the A people to say, well, maybe we can get E to fix things up someday or at some point, but meanwhile, we need to protect the integrity of our model. And that means that we will receive these sort of twisted AE messages, and we will translate them into nice, clean A messages before they come into us. So that anti-corruption layer is essentially a translator that takes messages of one language and turns them into messages in another language. And now we are back in a situation where even though there is some, there are several contexts here now that are not well designed, yet that doesn't inevitably lead to a degeneration of all the design in all the contexts. So we need a level of reality to prevent that. All right, so that's the first thing I wanted to get across, is what is it that made me think that microservices would be a good vehicle for domain-driven design? And basically it comes down to this kind of, you give a real isolation to the work within these different teams, within these different contexts. And you have a way of managing that. In most of the traditional techniques, it's much harder to make clear boundaries and enforce them. Now, one of the things that happens with any kind of, let's break things into smaller things approach is that you end up with a lot of small things. And it gets to be very hard to see the big picture, and it gets hard to make coherent designs on the larger scale. One of the common things that I see, though, what people often do with microservices is what I've dubbed the interchange context. And so let's look at this, for example. This is before E went off the rails. So we've got, right now we have 1, 2, 3, 4 contexts that receive A-type messages, in addition to A itself. So you have a lot of communication happening in this one language. This language is becoming the de facto interchange language. That is to say that more and more of these different services are speaking A. Now, that is actually pretty common, that someone designed it maybe, though, for quite a specific reason, and then it becomes used for that. Another way of doing it, though, if you were to anticipate such an interchange language, might be to try to devise one that was actually well suited to that. Remember that A language was primarily probably intended for the logic that A does, the way they think about the problem for their purposes, plus perhaps their collaboration with B, a very specific collaboration. But actually, E, D, C, they never were too interested in that. If you had designed a more generic kind of language for communicating with them, you probably would have chosen something different. And this is an opportunity that I think is not one that you'd want to do up front. But when you see something emerging like this, where you suddenly see that this service, this context is becoming the de facto language for a large part of the communication within a system, you might say, let's devise a new language that is just for that purpose. So this would be another context. This context does not correspond to a service. So context I is the first one up here that actually has no physical form at all. It's just a sort of way of talking about things. It's got crisp definitions that cover a range of things that these contexts like to talk to each other about. But it doesn't get into the kind of things they need in order to actually solve their internal problems, which probably A does have some baggage of that kind. As I say, I don't like to anticipate these things and do them before we start. I like to kind of let the need for it come upon us. Now, one of the things when I am talking with people who are not microservices fans, but actually, and I say, oh, I like the microservices thing. I think it's good for creating these boundaries and so forth. And they say, well, a lot of the things that you're saying you like are just logical boundaries. I mean, we don't really need all that machinery for this. We don't need separate deployment. Why would we do all this separate deployment stuff, sure, if you need to scale, scale some services at very different levels of scaling, and you need that kind of failover, and you need all those things, that's one way to do it. But the things that I've been talking about are not mostly about that. They're not mostly about that runtime side. They're mostly about the effects that that philosophy has on the development phase, right? And I'm saying, I think the effects that that has on the development phase seem to be quite good. And so I think they're undeniably right that there are, in principle, other ways to create logical boundaries. And my response is simply that we've been trying to do that for decades now, ever since I've been in this field. And I think before then, people have tried to establish those kind of logical boundaries in various subtle ways. And I think it's just too subtle. It doesn't survive the rough and tumble. It's always too tempting and too easy to pierce through the boundary and grab the piece of information you need from the database or whatever. And microservices, by putting all that machinery there, makes it actually unnatural to do that. It makes it more natural to do the thing that maintains the isolation. Sometimes, you need a wall. You have perhaps a fence between your house and the next house. You could just sort of draw a dotted line there, on the grass. But there's something about a wall. So I think that this is the reason, and I don't really have to understand it to have just observed that we've been trying to do this for a long, long time. But when I have introduced this approach in a project that was trying to isolate things in more logical ways, the physical isolation and the visibility it gave and other things seems to have done the trick and pushed us over into truly decoupling pieces of the system. So you may be driven mostly by the runtime advantages. You may need to scale parts of your system. The client that I did this with the first time really wasn't scaling that big. They rightly pointed out that they could handle the problem that they had without all that stuff. But we did it, and it produced a decoupling that allowed us to do the design better. Of course, if you need to do the scaling and the other advantages, then that makes it a much easier choice. All right, so basically my points are these, that when we want to do subtle design, and it doesn't have to just be domain-driven design, but any kind of intricate logic, we need clarity, a degree of precision that demands isolation. So we need some kind of concrete boundary. And I'll have to say that the best ones I've seen were the ones that have been cooked up in the microservices world. I'm sure it's not the only way to do it. It's just proven to be effective in my personal experience, and it's here, it's real. When you get a whole lot of these services, you're going to see some of the same problems crop up. Really, you describe a service, and when people start scaling the microservice down to, say, a nanoservice, where people start talking about a service that might have 20 lines of code in it or something, and I start thinking, boy, that sounds like an object. And because, and especially the way objects were in the old days, like small talk objects are little things that can send messages to each other and so on. And I think that there are, distinctions, of course. I'm not saying they are objects, but they're a lot like them, and some of the same problems will arise anyway. And so, this is not a panacea. It's not a solution to all the problems, but I think that some of those problems then can be addressed with tools like context mapping, which was specifically to address this kind of problem, to say you can understand a certain collection of elements that have been crafted to solve a set of problems, and then another set of elements which have been crafted to solve a different set of problems. But you can't understand all of it all at the same time. And furthermore, those different elements have been conceived using different concepts, different language. So we need boundaries between them, and then we need a way of seeing how they relate to each other. So the bounded context and context maps helps to make that explicit. Even, both in the situation where a service defines a context boundary, but also in the case where the communication of several services, where the message is going between them, defines a context. Not the interior of the services, but the messages between. That space in between is another context. It helps us to visualize that and reason about it. So I think that the modest use of interchange languages would be one way of helping to organize a coherent set of services that solves a somewhat bigger problem. And I think people actually do this, but without any explicit mental tools, to talk about it. Just say one more time before I wrap up that not all of a large system will be well designed. And you can and that I think is, a natural part of the microservices philosophy. It's one that we have to carry over even to the point of saying even the microservices properties won't be perfectly exhibited within a large system. There will be fragile parts, and there will be parts that don't scale right and so forth. Parts that get tangled with other parts in such ways that make it very difficult to do the things you talk about doing, of replacing and so on. But that's all right. This is not meant to create a perfect system. It's meant to get things moving and freshen things up. So, and on that, I'll close and hopefully leave some time for questions.
Yeah, we do. So thanks a lot for the talk. One of the questions from the online tool is, so in that design, all bounded contexts, ABC and so on, would they be separated microservices, and would they be separately deployed?
So the question was these contexts, the ABC and so on, would they be microservices that were separately deployed? And the answer is yes. That's what I'm suggesting. That in let's say an old-fashioned approach, we would try to define these contexts in other ways. Maybe they would be a certain set of modules and a certain set of tables that were associated with those modules, and you'd have maybe a document describing them or some kind of labeling within the comments, and all these ways of trying to say these are the boundaries of this context. What I'm saying about microservices is that one thing it seems to do is it says this service is a context. One team owns it. It's isolated. It doesn't share data. It shares data, but only through the interface. It doesn't share a database, and so on. And so the boundaries of this context are very well defined.
Okay. Then there is a question, the wall you called AC, what does it mean in the context map?
Oh, anti-corruption layer, yes. AC is for anti-corruption, and I guess I apologize for not defining that one. It's become such a common little abbreviation that we use that I forgot to. And the point of the name is that if I am consuming information, say a message that's coming from outside, that can corrupt my fragile, high-precision design, And so I have this, a car engine. is a very high precision machine that has to operate in a fairly dirty and uncontrolled environment. And what does it have? It has filters, right? The air that goes into the engine goes through an air filter. There's an oil filter that constantly is cleaning things so they don't get into the engine and so on. So they know that that kind of high precision thing, unless you're going to operate it in a clean room somewhere, in which case it doesn't need all that, well, that is a massive anti-corruption layer that's used for those kind of things, actually. So to have a really high precision solution, you need that kind of protection. On the other hand, not all problems are so high precision, right? The car's engine has all that kind of filtration and stuff, but the windshield wipers don't have that. They just swipe on the windows, and eventually they wear out, and we replace them. And there are low precision parts to a car, and there are high precision parts, and the high precision parts need to be treated differently. They need that isolation. And so if you're consuming data from outside that context, you can't assume that it meets the requirements that you would think it would have. So you check those things, and plus you transform it into the same terminology, the same structure that you would be expecting data that's moving around on the inside. And then once these are on the inside, you can make lots of assumptions and make assertions about the nature of the data that you're working with.
Okay. There is another similar question. So BBOM, what's that?
Yeah. So BBOM is short for Big Ball of Mud. And I actually did consciously decide to not use that term in the talk, and I forgot to take the BBOM off of the slides. But it is a wonderful, you should just Google for Big Ball of Mud and find the original Big Ball of Mud paper, which is from the 90s. And it describes systems that have just grown into big messes of tangled. But the great thing about that paper is that it describes these in a kind of admiring way, like how they observe that most big systems are like that, and that somehow it works, and there is something about anyway, it's a very clever paper. So I was just saying that we were getting some big balls of mud, but they probably weren't very big.
Okay, so more about the architecture. One of the questions is, can or should there be a dedicated service whose purpose is to only be an interchange context provider? I guess that was the I that you had in your chart.
Should there be a service dedicated to being the interchange context provider? I think that my answer would be no. I say it without a lot of confidence because, yes, you could imagine everything getting, but I think my answer would be no because the point here is keep the decentralization of the microservices architecture. Don't create some bottleneck and so on. But on the other hand, give us a way to exchange messages without quite so much translation, perhaps. And we can do that without having some kind of special service that I'm not sure what it would do, unless you had a database that stored things in that form. But basically, I think my answer is no. But if someone comes up with some solution, I'm not all that dogmatic about these things.
Okay. So another one that is more about the organization. So would you recommend a one-to-one relationship between teams and bounded contexts?
Would I have a one-to-one relation between teams and bounded context? I would have an one-to-in. That is, I want a bounded context to have a clear owner. Okay. So I would want to say, if this thing is a context, say a service, then there's a team that owns it. But a team might work on multiple services. So as long as you don't have, the problematic one is when you have two teams that work on the same thing. And you see that in places where they carry the concept of shared co-ownership too far in my view, without any context boundary separation, where anyone can change anything within the system. So people lightly touch a part of the system that they don't understand very well, and you have the tragedy of the commons and everything just kind of degenerates. So A context should have one owner, but a team might conceivably own more than one.
Okay, and does that mean that only the team is supposed to change the code of those bounded contexts?
That is what I mean, yes.
Okay, cool. And this, so this powerful separation that you're talking about, isn't that also a problem? Because if things don't turn out as expected, so if one of the teams doesn't really deliver, it's going to be hard to still find some way of going into production, and then you might have even the whole company fail.
So I think this is a problem, this idea that if one team fails to deliver, that it will lead to a kind of bigger failure. That is a problem which you would face under any circumstances. In fact, the microservices is perhaps a little more resilient to such things than more monolithic approach. But if you look at some of the diagrams, another nice thing about the diagrams, I think, is it can give you a hint about the consequences. Like if D doesn't come through, then probably it won't affect A very much. But if A, look how terrible it would be if A screwed up. So you know that the consequences of mistakes in A are dire throughout the organization. So I would say that it might help us know where to worry. And if I didn't trust A and I were C, I'd be thinking, maybe I should. Another thing I'll throw in here. One thing I've seen is that people sometimes value the dry principle too highly. That is the don't repeat yourself, the don't duplicate stuff too highly. So let's suppose that what A really wants what C is really wanting from A is some particular capability that really isn't that hard. I would rather see C duplicated. Of course, the ideal might be that this thing would be broken out and not be part of A or C, but remember, we don't have the ideal. But at any rate, if you've created a dependency on a whole other team and their success just to have this function that they've already built, well, maybe it's better to do some duplicating.
Okay. So I guess the final question, can we use the logical boundaries to create multiple microservices in a top-down way? And I guess closely associated with that question, does it make any sense to create a monolith first and then go for microservices?
What was the first part, though?
So whether you could use these logical boundaries to create multiple microservices top-down.
So would you sort of plan out and then...
Yeah.
I am not against a little bit of upfront planning, a kind of a sketch, and then let's go do something kind of thing, which I think is very different from meticulously planning everything out in advance. So I think such a thing, I think you actually are bound to do that a little bit, as you say, well, what are our first 2 or 3 services going to be? And we're going to have a couple teams working on them. Okay, let's go work on that now. So that is a little bit top-down, but not from very high up, right? And then the other part, does it make sense to make the monolith first? I actually don't think so, but people say that have experience and good results. And so although it goes a little bit against my sense, that I think actually that I would, at this point, I would start with something pretty broken up, actually. But I'm not going to, I don't think I have a very strong opinion about that one.
Okay. Thanks a lot again. Thanks a lot for answering the questions and the talk.
Thank you.
Thanks.